Welcome, everyone. Today, we're diving into the fascinating world of statistics, one of the most useful and essential tools in both everyday life and professional fields. Let's start with a simple question. What is statistics? Well, it's the science of collecting, processing, and analyzing data to help us make decisions. Think about the last time you made a decision based on numbers, whether it was looking at grades, shopping discounts, or even health statistics. That's statistics in action. Throughout this lesson, we'll explore how statistics allows us to gain insights and make informed decisions. Whether you're measuring the performance of a business or predicting future trends, statistics plays a central role. So, let's go back to our earlier question. What is statistics? Statistics is essentially a method for studying data so that we can make decisions. For example, companies use statistics to determine how their products are performing, while doctors use it to understand patient outcomes. We'll break this process down step by step. We collect data, process it to organize it, summarize it in meaningful ways, and finally, analyze it to answer questions or solve problems. It's all about making sense of the world through numbers. Now, why should we study statistics? Good question. First off, statistics is an amazing tool for decision-making. It allows us to characterize persons, objects, and situations. Statistics helps us characterize persons, objects, and situations by summarizing large sets of data into meaningful insights, such as demographic profiles or product usage patterns. For example, we can use statistics to summarize a population's demographic profile or understand product usage patterns. Explain relationships among variables. Have you ever wondered how income affects spending habits? Statistics can help us discover relationships like these. It allows us to explain relationships among variables, such as determining how changes in one factor example income affect another example spending habits. Formulate objective assessments and comparisons. With statistical methods, we can make unbiased comparisons, like determining the success rate of two marketing strategies. Using statistical methods, we can formulate objective comparisons between different groups, products, or trends, reducing bias in assessments. Simply put, statistics helps us make evidence-based decisions that are grounded in reality, not just assumptions. It enables us to make evidence-based predictions by analyzing past trends, leading to more reliable future forecasts in fields like economics or healthcare. Now, let's talk about variables, the building blocks of statistics. There are two main types of variables: qualitative and quantitative. Qualitative variables describe attributes or qualities that can't be measured with numbers. For example, think of gender, religion, or marital status. These variables answer questions like what kind and what type. It can families of dogs, foods or snacks, and fishes. Quantitative variables, on the other hand, deal with numbers and measurements. These answer questions like how much or how many. They help us measure things like height, weight, areas, volumes, temperatures, money, or test scores. Both types of variables are important, but they serve different purposes. So, whenever you encounter data, ask yourself, is this qualitative or quantitative? Quantitative variables can be further divided into two categories. Discrete variables are countable. Think of things like the number of students in a class or the number of cars in a parking lot. There's a specific, countable number. Discrete data deals with whole numbers. Continuous variables are measurable and can take on any value, including decimals. For instance, a person's height or the amount of water in a glass can be measured in exact values. Continuous data is more fluid and can take on a range of values. Understanding whether your data is discrete or continuous will help you choose the right statistical methods for analysis. Now, let's dive into the levels of measurement. There are 4 main levels, and they help us understand how to handle different types of data. A nominal data is purely categorical. For example, assigning 1 to represent males and 2 to represent females. We're not saying one is greater than the other, just labeling them. Other examples are gender, male, female, hair color, blonde, brown, black, nationality, American, Canadian, Mexican, blood type, AB, ABO, marital status, single, married, divorced, eye color, blue, green, brown, religion, Christian, Muslim, Hindu, vehicle type, car, truck, motorcycle, favorite fruit, apple, banana, orange, and political affiliation, Democrat, Republican, Independent. Ordinal data involves ranking. Imagine the results of a race: first, second, and third place. There's an order, but we don't know the exact difference between each rank. Examples are education level, high school, bachelor's, master's, PhD, ranking in a race, first, second, third, movie ratings, poor, fair, good, excellent, satisfaction survey, very dissatisfied, dissatisfied, neutral, satisfied, very satisfied, income bracket, low, middle, high, military ranks, private, corporal, sergeant, lieutenant, letter grades, A, B, C, D, F, pain scale, none, mild, moderate, severe, job positions, entry level, manager, director, and hotel star rating, 1 star, 2 star, 3 star, 4 star, 5 star. Understanding these levels helps us apply the right statistical tools based on the type of data we're dealing with. Next, we have interval and ratio data. Interval data is where the difference between values is meaningful, but there's no true zero. For example, temperature in Celsius. 0 degrees doesn't mean there's no temperature, it's just a point on the scale. Another are temperature in Celsius. 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius. IQ scores, 80, 100, 120. SAT scores, 200, 400, 600. Dates, year 2000, 2010, 2020. Time of day on a 12-hour clock, 1 p.m., 2 p.m., 3 p.m. Altitude above sea level, 10 meters, 20 meters, 30 meters. Calendar years, 1990, 2000, 2010. Scores on a personality test, 5, 10, 15. Shoe size, size 6, size 8, size 10, and GPA, 2.5, 3.0, 3.5. Ratio data is the most precise. It includes a true 0 point, meaning 0 actually means none. Examples include height in centimeters, 160 centimeters, 170 centimeters, 180 centimeters, weight in kilograms, 50 kilograms, 60 kilograms, 70 kilograms, age, 5 years, 10 years, 20 years, income in dollars, $10,000, $20,000, $30,000, distance traveled in kilometers, 5 kilometers, 10 kilometers, 20 kilometers, number of children, 1, 2, 3, time taken to complete a task, 10 minutes, 20 minutes, 30 minutes, volume of water in liters, 1 liter, 2 liters, 3 liters, and speed in miles per hour, 30 miles per hour, 40 miles per hour, 50 miles per hour. By identifying the level of measurement, you can better understand the properties of your data and how to analyze it. Thank you for watching this video on Math and Phil Tech TV. We hope you found it informative and engaging. If you enjoyed the content, please give it a thumbs up and don't forget to subscribe to our channel for more videos like this. Hit the notification bell so you never miss an update and share this video with your friends and fellow learners. Your support helps us continue to create great content. See you in the next video.